we introduced NeRFReN, neural radiance fields with reflections. Neural radiance fields, or NeRF, is the state-of-the-art method for novel view synthesis. It models the density and radiance of each spatial location with a neural network, and synthesizes pixels by rate marching and volume rendering. NeRF is able to handle view-dependent effects by taking the view direction as network inputs. However, we found that the view-dependent effects are not always explained by view directions in NeRF, especially in scenes with complex reflections, like those from mirrors or glass. Here we show the view synthesis results and depth estimations of NeRF on two such scenes. NeRF regards the reflections as objects appearing at the virtual image depth, leading to inaccurate depth estimations and may cause artifacts in some synthesized views, like the areas in red circles. If we take a closer look into the density distribution along a ray in the reflected area, we can find it to be bimodal, with one peak appearing at the real depth and another at the virtual depth of the reflection image. Taking inspirations from traditional view synthesis methods, we propose to split the scene into a transmitted component and a reflected component, both modeled with neural radiance fields. The images rendered by the two radiance fields are combined by a learned softmask beta, which we call the reflection fraction map. This map roughly indicates the surface material. Under this decomposition, we can take the expected termination depths of the transmitted component as a more accurate depth estimate. The decomposition is highly under constraint. We specifically design a two-branch network where the reflection fraction only depends on the transmitted component, and introduce view dependency to transmitted color to explain simple reflections like highlights. We also exploit two geometric priors, namely the depth smoothness term and the bidirectional depth consistency term. Details can be found in our paper. Due to the lack of real-world datasets with strong reflections for the view synthesis task, we captured 6 forward-facing scenes with strong reflection effects caused by glass and mirrors. Here we show the decomposition results on some of the scenes. Our method successfully decomposed the scenes into transmitted and reflected components, giving high-quality view synthesis and depth estimation results. We compare NeRFReN with the vanilla NeRF representation. NeRFReN produces clearer reflections, as well as more accurate depth maps. Here we show a scene editing example as a natural application of our representation. This could be utilized to synthesize self-reflections of the user to provide more immersive experience. Thanks for watching. To know more about this work, please refer to the paper in our website.